Okay, good morning. Let's have a quick review of what we have discussed so far in multiple linear regression. Okay, what we have done was to model hourly wage using several variables. And we looked already at the concept of a simple linear regression. Okay. We also, last time, we compared a model with no predictions. And how do we do that? We're regressing our dependent variable. And till day one, this model will give us a zero-based model, which means we're not using any predictor, but just the average of our dependent variable. We did this last time, and we can see here that this model generates no coefficient because we're not using any exogenous variable, just hourly wage itself. And we have learned that this is actually the average of hourly wage. We have some statistics here, like the standard residual standard error, which we can easily compute, okay, which is just the square root of your standard sum of the squares of your residuals divided by your degree of freedom, and then the square root of that. Okay, we were able to show that last time. And we can do an ANOVA for this model 0. And we ran this last time, and we saw that this ANOVA will just give us the details about the degrees of freedom, which is n minus k minus 1. Your k is 0. We're not using any predictor. And so that's 526 minus 1. The 1 there is for the degree of freedom lost for computing the intercept, which is the mean in this case. All right. So this is the mean square error, which is just the sum of the squares divided by your degree of freedom. And then when you get this, when you get the square root of this, let's get the square root of 13.639, Control C, Control V. Okay, that's your 3.693. This is what I was referring to you as the square root of the sum of the squares of your errors divided by your degree of freedom. Okay, and the residual standard error is akin to a measure of the standard error of your error terms. Okay, of course, the higher the residual standard error, the poorer is your model. Okay, so let me just check. Wala ba? Di ba naka-share screen ako? Am I sharing my screen, class? Hello?
Sir, nawala po.
Nawala. Okay, sorry.
Sir, naghang po ata kanina, sir.
Naghang ba?
Yes,
okay,
sir.
How about this one? Is my screen sharing already?
Yes, sir. Moving na po.
Okay, thank you. All right, sorry about that. Class, let me just backtrack to what I did. Maybe you missed that out. So I just showed here model 0, which is what we did already in the past. It's just regressing our dependent variable on 1. Okay, this is to indicate that we're not using any exogenous variable. We're not using any variable from our data. We're just using hourly wage itself. And the result is that the prediction is just the mean. Okay, wala siyang model, no? Ito lang. So regardless of any observation, we're not using the education, the race, etc., in order to predict hourly wage. It will just be 5.896. And with that, you can compute for the sum of the squares of your residuals. You just compare the actual value of your hourly wage with the mean. Okay, get the difference, square that, and then get the total. You will get it's not shown here, okay, but it will be shown in the analysis of variance of your model 0. And this is it, 7160.4. So where did this come from? It's the actual value, the hourly wage, minus the average hourly wage, which is 5.869, right? This one. Okay, let me just quickly, let's just validate that very quickly. Control-Alt-I. So we can get so SSE. sum of the squares of your error. This is for say, just to validate class, just to make sure that I just want to make sure that you understand where these figures are coming from. Okay, the actual hourly wage can be obtained from your wage data, right? So let's see, wage data, and then hourly wage. There, this is your actual data, and we're going to subtract from it the model. The model value is the mean, right? Which is this one. This one, 5.896. Okay, or you can just get another way to go about that is get the fitted values of your model 0. Okay, the fitted values of your model 0 is just the average itself. Okay, let me just show this so that we know how to navigate through. Okay, here, model 0, here, list. They take a look at the fitted values. The fitted values are the same, 5.9, 5.9, 5.9, it's 5.9 something. Okay, that's your fitted values, right? That's your predicted value, and your predicted value is not changing because we said that this model just uses the mean for your predicted value. So we can use that. So model $0 fitted value, or you can just get the average, okay? The average of hourly wage, which is just the same, okay? And then so you get the difference between the actual and the model value or the average, and then we square this, right? We don't just add them, because if we add them, we're going to get 0. Let me just show you. If I add this, we'll get approximately 0 because that's the definition of the mean. Okay. So let me print this. There. So that's practically 0, right? Okay. So that's not what we want. What we want rather is we get the square root of the difference, and then we get the sum. So that will now give us the sum of the squares of your error terms. Okay. So that's now your 7160.14. There you go. Okay, we were able to validate that. And then when you divide that by the degree of freedom, which is n minus k minus 1, you get the mean square error. Okay, the MSE. And then when you get the square root of the mean square error, you get your RSE, your residual standard error, which is this one. So all of these values, guys, they fall into place. Okay, it's a matter of understanding how you got those values. Okay, but what's important for us now is, okay, so we now compare this with Model 1. Okay, Model 1, we said we're going to use education. So we have a summary for Model 1. Okay, I'll not anymore look into Model 1. We have done it several times. But the question now is, in Model 1, anyway, I'll just show that. In Model 1, we have this. Okay, we have your F statistics. And we said that this has a null hypothesis because we're inferring here. The presence of the p-value and the f-stat indicates that this is an inferential statistic. So what's our null hypothesis here? We're comparing Model 1 and a certain model. Okay, the certain model that we're comparing it to is Model 0. So we said that, okay, ang Model 0 natin, di ba? Ang Model 0 natin, Model 0, we don't have any predictor, right? No predictor. But Model 1, our predictor is, for Model 1, our B1 is education. So the inference here is that we're going to compare, is this this model, the one without any predictor, more valid than this one? So here the null hypothesis is, we said, what's the difference in Model 0 and Model 1? The difference is the presence of education. So here we're trying to see if B1, which is your education, we're trying to see if this is equal to 0, if this is statistically different from 0. And we have seen the answer, it's this one. Okay, but this is not, remember, this is not the actual P. Okay, this is just the minimum non-zero P. Okay, so another way to look for that is compare the ANOVA. Okay, and that we did last time. Diba ito? Nag-ANOVA tayo ito. No? This one. ANOVA, Model 0 and Model 1. If we run this, all right. So we're comparing two models. Model 0 is this one, hourly wage regress on education, hourly wage regress on nothing, just the average, and hourly wage regress on education. Okay, so here, this is your, okay, be sure to understand this. This is your restricted model. Okay? Restricted siya kasi mas konti yung predictor niya. Wala siyang predictor actually. No? We're just using the mean. This one is your unrestricted. Okay? So take note, class, the unrestricted model is the one with more predictors. Okay? In another instance, okay, yung model 2 natin dito, which is we call model 1, could be the restricted model. And the null hypothesis here for this analysis of variance is the one andun sa ano natin sa regression output, which is B1, which is your education, is equal to 0. Okay? So this is our null hypothesis. Okay? Sabi natin yung overall goodness of fit kanina doon. Ano ba yon? Ito yon, analysis of variance. Okay? So we're testing this. And our conclusion is that the p-value is practically 0. This is significant at 0.001. So we reject this null hypothesis that B1 is equal to 0. There's strong statistical reason to believe that your B1 is a value other than 0 by virtue of this analysis of variance. Okay. All right. Clear so far, class? May I have your confirmation if that part of our discussion is clear? I would appreciate your feedback kung clear so far yung discussion na yan.
Sir, question lang po.
Yes, sure. Go ahead.
So ibig sabihin, sir, di ba yung tama, sir. Yung education may significant effect, no? Tama, no? Sa model.
Yes. Which means that B1, education, is not equal to 0. Okay? In fact, dito sa model natin, ito yung average value niya. 0.541. And this value, this B1, is statistically significant. So, hindi siya hindi siya possibly 0. If you take a look at, let me see, conf int, let me see if I conf int lm, tinan ko lang let me check if my memory serves me right. Conf int.lm from the stats package, let me see, mod 1, let me see if this will give me the correct output. All right, sige. Let's use this class. Okay, I'm using this confidence interval ng LM model natin ng model 1. Okay? If I run this, okay, tingnan niyo to, class, no? It will give us the values of the lower and upper values ng ng predictors, no? Education. Ang sabi dito, okay, if we plot yung natin, so our mean value ng education is 0.54 something, di ba? 0.54, 0.54, and it ranges between, okay, 0.44, round off ko na lang, at saka 0.65. Okay, so this one accounts for 95%. Okay? So ang sinasabi nito, meron tayong 95% confidence na yung value ng education is between 0.44 and 0.65. And take note, it does not touch 0, di ba? Between 0.44 and 0.65, hindi pwedeng tamaan si 0. Okay? So that's what this means, yung probability na less than 0.05, B1 is equal to 0. Take note of the intercept naman. Tingnan nyo, ito. Diba? Ito, negative 2.25, tapos yung upper value niya 0.44. So ang question dyan, may possibility ba na tatamaan si zero? Yes. Kasi ito negative 2.25, tapos ito naman positive 0.44. So between these two values, yung lower limit natin at saka upper limit, tatamaan dyan si zero. That's why si intercept natin is not significant. Okay, if you take note, di ba? Okay, pause muna ako bago ako punta sa intercept. Clear to class, yung ginamit ko na confidence interval .lm, yung regression model natin, tapos kinuha natin yung model natin. It will give us yung lower and upper limits ng values ng natin, ng predictors natin, and even the intercept. Okay? So if the interval, okay, if the interval touches zero, okay, between the lower and the upper, kung tatamaan si zero dyan, then that means that there's a possibility that the value of that particular parameter is zero. Now, sa education, tingnan nyo okay, lower 2.5, tapos dito sa upper 2.5, okay, in between these two is 95%. So, okay, kasi ito yung ito 2.5% probability. This is another 2.5% probability. No? All in all, that's 5%. Sa gitna na, 95%. So we're saying that there's 95% possibility that your education will be between 0.44 and 0.65. And it will never, never, never touch zero. Hindi siya possible maging zero kasi parehong positive yung values na yan. Okay, is that clear, class? Yung concept ng confidence interval. Paki-chat naman please kung clear yung discussion na yan. Let's wait for the others to give their feedback. Waiting for the others, class. Dalawa pa lang yung nagbibigay ng feedback. Any questions, class? Any questions? Clarification dito sa in-introduce ko lang. Gusto ko lang pinakita ko lang to kasi there was a question on the value, no? On the probability of education. Okay? Dito hindi pinapakita dito kasi sa Excel pinapakita yung sa Excel if you generate a regression output in Excel, meron dito yung lower confidence limit at saka yung upper confidence limit. Okay? Dito nakita natin, tingnan nyo to, sorry. P-value ni intercept is greater than 0.05, diba? Kaya we reject the null hypothesis that beta 0 is equal to 0. There is a possibility that yung natin, yung intercept natin is equal to 0. And that was shown by the confidence interval natin kanina. Diba? So ito, ang possible values ito kasi ang average natin. No? And we were able to show that the lower limit here is around 0.44. The upper limit is around 6.65. Okay? So, yung value natin, yung average value ng education natin is between this 0.54. And we are 95% confident, okay, that the true value of your education lies between these two figures. And what we use is the mean, the average, yung 0.54. Okay, clear yan, class? Clear? Okay. All right. So, going back, class. Okay, and then last time, sabi natin, kahit there are different ANOVAs, no? Merong ANOVA coming from the car package. Itong stats, ang ginamit natin kanina yung stats package. Tapos meron ding AOV, analysis of variance. So medyo may iba-ibang flavor sila. Okay. Ako, personally, I prefer yung sa stats package kasi mas Mas kompleto. Although okay din yung sa ano, no? Itong sa AOV. But I don't know if we ran this last time. Sige, ipakita ko nga to. Okay. All right. So, ito pinapakita sa atin yung sum of the squares education, which means this is your SS regression. No? Ito yung kaya i-explain ni education. Ito residuals, ito yung hindi kaya i-explain ng model natin. Ang total nitong dalawa, 7,000 plus, is the sum of the squares of your total. Then we have the degrees of freedom here. Okay, we have the RSE here. Okay, yan ang pinapakita sa atin ni AOV. Okay, and another way naman, itong pinakita natin kanina, ito, no? Yung from the stats package. Okay. So, para sa akin, complete tong small a ANOVA from the stats package. Similar din yung capital A from the car package. Now, take note, pag isang model lang nilalagay natin dito, ang underlying principle niyan, kino-compare niyan sa model 0. No? Sa isang model na there is no predictor. Okay, now that's important because later on, when we compare models, kailangan, pwede natin sabihin kung anong models ang kino-compare natin. And then use ANOVA. Okay, so last time we started looking at the, at the next model natin. So ito yung model natin, di ba? Itong model 1 natin is we're using, model 2. This one, which is using all your regressors in the wage data set. So, or we can spell that out: education, experience, tenure, race, gender, civil status, etc. Okay, and we already ran this before, so let me quickly just run this. I'll just use this, yung tilde dot, which means all of your predictors. All right, and last time we studied this, diba? Okay, very quickly, let's just have a quick review of what this model generated, yung model 2 natin. Okay, andito yung formula. Hourly wage regression, all your variables from the wage data set. Okay, then you have your residuals here. Then you have a list of your predictors. And you can see that some of the predictors are significant while the others are not. No? Yeah. Something's wrong again with my mouse. All right. So here, we can see here that education, tenure, and gender are 3 variables that are statistically significant at 0.001. Ito. Significant sila at 0.001. Experience is significant only at the 10% level of significance. No? The others are not significant. Now, we studied this last time. Diba? Sabi natin na itong mga yung mga values na to, may mga meaning yan. For instance, education. It's statistically significant, diba? Here, 3 stars. Significant at the 0.001 level of significance. Okay. Ang estimate niya is 0.57458, which means that on the average, for every 1 unit, 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, ceteris paribus. Always ceteris paribus, no? Okay, also tenure. For every 1 in years din to, no? This is also in years. So for every 1 year increase in tenure, there's a corresponding $0.138 increase in hourly wage, ceteris paribus. You can see that education has a higher marginal impact on hourly wage as compared to tenure. No? Ito 0.57, ito 0.13. All right. Then we looked at yung mga yung mga factors natin. We said that there are 3 factors here. No? Si race, si gender, at saka si civil status. So quick review class. Si race natin, okay. Ang tanong class, ilang levels yan? And we can use yung table function ni R, okay, table, all right? wage, dollar, raise. Okay, we can plot. So non-white at saka si white. Okay. So what will R do? This is a categorical variable, right? It's a categorical variable. It's a character variable. However, we said that it can be used as a factor. Okay, so may mga character variables, categorical variables that can be used as a factor. Okay, qualitative variables, but not all, no? So, nasa sense naman ni Aryan, minsan nagkakamali siya. So, we'll have to just correct that. So, here, ano ginawa ni R? Bakit nagkaroon ng value yan? Ba't nagkaroon ng value let's go here, si gender. At saka ba't nagkaroon ng gender male dito? Now, I explained last time, now what R automatically does is to introduce dummy variables. So magkakaroon ng dummy variables. What are dummy variables? Okay, dummy variables convert your categorical or factor variables into values of 0 and 1. So for example, si gender. Si gender, dalawang level siya, female at saka si male. So what R will do is that ang default niya, yung level, yung category which will come first alphabetically, it will be treated as your benchmark. No? Benchmark or your reference variable. Ang ibig sabihin ng benchmark or reference variable, it will take on the value 1. The other one will take on the value 0. So if we take a look at the wage dataset, ito, no? Saan yung wage dataset natin? Is it printed? Hindi. Okay. Clear ko muna. Okay, so wage. Let me just print out wage ito. Wage. All right, so let me just explain again what's happening here. So kapag factor class, kapag categorical variable that can be used as factor, R will automatically convert it into a factor. Okay, kunyari si gender, no? Female, male. So R will introduce one dummy variable. Ilang dummy variables ang i-introduce? It will depend on the number of levels. So the number of levels minus 1. So in this case, yung yung gender, there are only 2 levels, female at saka male. So 2 levels minus 1, so only 1 dummy variable. So itong gender na to, magiging dummy variable siya. So pwedeng ang ginawa ni R, ginawa niyang gender male to. He made it into a gender male variable where lahat ng female 1, 1, 1, lahat ng male 0, 0, 0, 0, etc. Okay? All right, so this way, okay, you are able to convert your categorical variable into a quote-unquote numerical variable. Only that it's binary, 1 or 0 lang. Pero pwede natin magamit ngayon sa pag-compute yan, sa regression. Okay? All right. However, kunyari meron tayong 4 levels, no? Frosh, ito yung example natin, I think last time, sophomore, senior, and let's say 5, junior and let's say junior, senior, and graduating kunyari, no? 5-year levels. So what will happen, class, kung 5-year levels? It will be 4 dummy variables. Kasi 5 minus 1. So ano yung magiging dummy variables na yan? It depends. Pwede maging, first, kita na ni R, sino yung alphabetically, which will appear first? Si Frosh. So gagawin niyang si Frosh, ang benchmark, all the Frosh, okay? Pag ganito karami, iba yung kakalabasan nito, no? So merong 4 dummy variables, may sophomore dito, may junior, may senior, at saka may graduating. Example. If the student is, let's say, sophomore, then 1 yan, 0, 0, 0. Okay? If the student is Frosh, then 0, 0, 0, 0. If the student is graduating, 0, 0, 0, 1. If the student is senior, 0, 0, 1, 0. if the student is sophomore 0, 1, junior 0, 1, 0, 0. So in all cases, class, kaya ng apat lang na dummy variables. You don't have to put here another variable, f, no? Okay, f. So kunyari si Frosh, gagawin siyang 0, 0, 0, 0, 1. Okay, we don't do that. Kasi magkakaroon tayo later on ng what we call multicollinearity. Okay, multicollinearity, or others call this the dummy variable trap. Okay, dummy variable trap. Okay, so for factors, only L minus 1. L refers to the number of levels. Yung levels will be the types. Kung ilan yung granularity ng data natin. For example, ito, si civil status, dalawa lang yan, di ba? Single or married. So what will happen here is married, which happens first, no? Alphabetically. This will get 1 and the other will be 0. Yun na ginagawa ni R. So lahat ng single dito 0, lahat ng married 1. 1, 1, 0, 0, etc. Ganon din dito sa race. Non-white, white, therefore white will become 1. Si non-white will become 1, si white will become 0. Okay? So ang mangyayari, yung variable na hindi benchmark, okay, yung ginawang 0, siya yung lalabas sa output natin. Okay, so let me show that. Asan na yung ko? Clear drawings, X. So if we take a look at the output here, yan, di ba? Ito class, no? You can see here, race white, no? Kaya R2, other softwares will have their other conventions. But most, ganito yung gagawin. Take note, si R, ginawa niyang race white. In-attach niya yung hindi benchmark. Okay? To remind you that si race white dito, pag in-interpret natin yan, it should be interpreted in light of the benchmark variable. The benchmark variable, as far as race is concerned, is non-white. Bakit siya naging benchmark variable? Siya yung unang mag-a-appear alphabetically. Okay, in the case of R. So, without us giving instructions, ginawa na ni R na ganun. Actually, we can, if you want to change that, pwede natin gawin na si white yung benchmark. That can easily be done. But let's do that next time na lang. Ang importante dito yung interpretation. Okay, so let's assume that race white is significant. Hindi siya significant, di ba? Kaya there's no sense in interpreting this. Kasi hindi naman siya significant eh. Ang ibig ng not significant class, there's a possibility that this is 0. Okay, yun ang ibig sabihin pag hindi significant. There's a strong statistical probability that this value is 0. Kung 0 yan, class, walang effect kung white o non-white, no? Okay, so let's just assume that this is significant. Ang purpose natin is to understand how this is to be interpreted. So if this is significant, and I'll just round it off to 0.11, so that can be interpreted as, okay, white, okay, on the average, white employees receive $0.11 more than their non-white counterparts, ceteris paribus. So itong white na to, class, it will be interpreted in the light of your benchmark variable. Okay? In the light of your benchmark variable, which is non-white. Okay? Ito din, no? Si gender male. So male, which is your quote-unquote non-benchmark, will be interpreted in the light of your benchmark, your reference variable, which is female, no? So ito, and it's statistically significant, ha? So dito, ang sasabihin natin, on the average, male employees receive $1.76 more. Bakit more? Kasi positive to. More than their female counterparts, ceteris paribus. All things being the same. Okay? So si female, 0.175 less siya than the male counterparts. Okay. Actually, class, pag binaliktad natin, kung ginawa natin kunyari si male yung reference, kasi pwede yon, no? Pwede. Ang magiging value niya negative 1.76. Okay? magiging negative 1.76 lang siya. So it doesn't matter, class, what the reference variable is. Basta alam natin ma-interpret. Okay? Ito, sabi natin, ang default ni R, kukunin niya yung alphabetically mauuna, yun ang gagawin niyang benchmark, yun ang gagawin niyang 1, the rest will be 0. Okay? And when you interpret this, male employees on the average receive $1.76 more than their female counterparts, ceteris paribus. And single employees receive $0.46 less kasi negative to than their married counterparts, ceteris paribus. Unfortunately, hindi siya significant, no? So we don't put any interpretation to that. Okay? All right. I-assume natin na lahat ng lahat significant. Okay? If this was all significant, ang question, what will be the interpretation of the intercept? Okay, so what's this? Yeah, what's the meaning of the intercept? It's a negative $3.39. Can anyone tell me, how do you interpret the intercept, class? Okay, listen carefully, interpret ko. Okay, the negative 3.39 there, I'm rounding it off, class. That is the average hourly wage, negative. Although sabi natin walang physical significance yan kasi hindi naman pwede magkaroon ng negative na hourly wage, no? Pero just so we know how that is interpreted, no? Negative 3.39 is the average rate, no, of an employee who is what? Who has no education, okay, no experience, no tenure, right? Tapos, who is what? Who is what, class? Who is?
Non-white, sir?
Non-white? Yes, correct. Tama, no? Ulitin natin, On the average, yung negative 3.39 na yan, that's the average wage of a person with no education, no experience, no tenure, who is non-white, who is female, who is married, and who has no number of dependents. That's the meaning of the intercept there. Bakit naging non-white? Class, bakit naging non-white? Kasi, class, di ba? Zero lahat yan di ba? Zero lahat. This one is your white. Di ba? White to Pag siniro ko to, class, what is this referring to now? Yung non-white na siya. No? Di ba? Kasi this has something to do with the white in reference to your non-white. So if I make this 0, class, that means I'm referring to the non-white. If I make this 0, that means I'm referring to your female. If I make this 0, that means I'm referring to your married, who also does not have any number of dependents. Okay, so that's the interpretation of that. Okay, so be careful, class, when you're interpreting yung intercept ngayon, dapat lahat sa 0. And yung mga factors natin, pag zero out natin yan, pag 0 to, ibig sabihin, you're now referring to your reference variable. Okay, itong male, pag zero out natin yan, ibig sabihin, you're now referring to your reference variable, which is female. Itong, pag zero out natin itong single, ibig sabihin, you're now referring to your married, no? And then 0 yung number of dependents. Okay. All right? Okay, so sige, tuloy natin Okay, so now, what will the model appear now? Strictly speaking, ang papasok lang sa model natin, itong intercept, and we said, yung intercept, kahit na hindi statistically significant yan, pinapasok pa rin natin by practice. No? Education will enter the picture, tenure will enter the picture, gender will enter the picture. So the rest, is not going to enter the picture. Not even experience, kasi if we're going to stick strictly to thank you, Rowell, nga pala. Stick strictly to the 5% level of significance, hindi papasok si experience. Okay, but in practice class, okay, we don't do that, no? Hindi natin tinatanggal kagad lahat ng mga insignificant. So there's what we call a stepwise regression. So ano yung stepwise regression? Yung stepwise regression, isa-isa natin tatanggalin, no? So that's what we do. But before we do that, before we engage in stepwise regression, okay, take note here, meron tayong ano dito, meron tayong again, may ano tayo dito, overall goodness of fit test, no? May ANOVA tayo dito. So ano yung tinetest natin dito? What are we testing here? Yung result dito, class, is testing model 0 compared with model 2. Bakit? Kasi itong ANOVA na to, class, ang kino-compare natin dito, yung walang predictor versus may 7 predictor tayo. But we don't want that. What we want to compare is yung model 1 natin, okay, this one, yung may isang predictor tayo, at saka yung model 2, yung may all the predictors, right? That's what we want to compare. Kasi we already know that model 1 is better than model 0. So we're not interested in comparing model 2 with model 0. What we're interested in is, mas maganda ba si model 1, yung education lang, o si model 2 na maraming kasama? Okay, si model 2 kasi ilang predictors? Education, experience, tenure, race, gender, civil status, number of dependents. 7. So 7 degrees of freedom. 7 minus 1, okay? So dito, class, quick answer, which is the restricted model, class? Which is the restricted model? Everyone, please. Dito, model 1 and model 2. Sino yung restricted model dito? Answer, please. Come on, class. Paki-sound off na lang, no? Sino yung restricted?
Model 1.
Yes, model 1. Bakit? Kasi iisa lang predictor nito, no? Education lang to. Iisa lang predictor niya. Ito yung unrestricted natin kasi mas marami. Ito restricted. So, ilan yung difference sila ng sa degrees of freedom? Ilan yung difference dun sa class? If babalik lang ako. If you recall, how do you compute for the F-stat ng analysis of variance? It's the sum of the squares of your residuals ng restricted minus sum of the squares of residuals ng unrestricted. And we know that the sum of the squares of your error terms ng restricted will be greater than unrestricted kasi mas konti lang yung predictors nito eh. The less predictors, the greater will be the sum of the squares of your residuals. And then we divide this by the degree of freedom ng restricted minus degree of freedom ng unrestricted. And then everything divided by sum of the squares ng unrestricted over degree of freedom ng unrestricted. So this is how you compute for your F-stat, no? Okay? And then from here, you'll be able to determine kung mas kung i-reject man natin null hypothesis. Ang null hypothesis natin, mas maganda si restricted. Mas maganda yung konti, no? Alright? So ito, class, tingnan natin to, no? Ilan yung degree of freedom ng restricted natin? N minus K minus 1. Ilan yung degree of freedom ng unrestricted natin? N minus K minus 1 din yan, di ba? Kung i-minus natin yan, ang magiging difference lang, class, yung K. Di ba? Yung K lang. Alright? Ilan ba yung K ng natin? Ilan yung K ng ng restricted? Di ba? Isa lang, di ba? 1. Right? Kasi isa lang yung predictor natin dito. Dito, class, ilan yung K ng natin, ng unrestricted? Lahat ng mga variables. 7, di ba? 7. Okay. So, ang difference sila, class, is 6. Okay. So, ito yung tinitingnan natin. So, actually, ito divide by 6 to. Divide by 6. Okay. The divisor here will always be the difference between the number of predictors. Okay. Kung ang difference lang ng predictor nila isa lang, so this will be over 1. Kung ang difference ng predictors will be 6, in this case, 6, then divide by 6 to. Okay? I hope that's clear, class, no? And again, ang tinitingnan natin dito, ang null hypothesis natin dito is the restricted model is better. You must konti. Kasi, ang tanong natin, ano ba yung, does it make sense to include the other variables? Okay. Ang long cut nito, class, the long cut here ng null hypothesis natin is B2 is equal to B3 is equal to B4 is equal to B5 is equal to B6 is equal to B7 is equal to 0. Okay, bakit ganyan ang class? Bakit ganyan? Kasi, ang mga dinagdag natin ng variable sa unrestricted is B2 hanggang B7. Pareho silang may B1, di ba? So that, walang difference tayo doon. No? Kaya ang tinetest natin, kung by adding B2 hanggang B7, gumanda ba yung model? Alright? So that's the story here, class. That's the story of this result here. Okay? Yun nga lang ito, iba yung F statistic natin dito kasi ang kino-compare natin dito, model 0 versus model 2. Pero pagdating natin dito si ANOVA, pwede natin i-compare si model 1 at saka si model 2. Sige, let's run that class. Okay. I'm sorry if I keep on repeating this, no? Kasi gusto ko lang talagang ma-appreciate natin to before we really move on to the next one. So ito, ANOVA model 1, model 2, you can use the AOV, can use yung capital A from the car package. Let's just use this from the stats package. Run natin. And then here, tingnan nyo, class. O, di ba? Ito. Yung unang model natin, may education. Yung pangalawang model, may education, pero may nadagdag. B2, B3, B4, B5, B6. Okay. B7 pa pala. Sorry. Alam ko, hanggang B7, may number of dependents ito. So, ang difference nila, ang degree of freedom ng model 1 natin, 524. That's n minus k minus 1. Isa lang yung predictor. Ang degree of freedom natin ng model 2 is n minus k minus 1. Yung k natin doon, 7. Okay, so ang difference sila, class, ito yung sinasabi ko kanina, yung 6. No? Yung q natin is 6. The difference in the number of predictors. Ito, 1 predictor. Ito, 7 predictors. 7 minus 1 is 6. Kaya nga ito, class, yung difference. There. Okay? So what do we have now? A p-value is this one. Okay, p-value natin, yan. So, anong natin, ang inference natin? We reject the null hypothesis that yung restricted model is better. No. Okay, there's strong statistical reason to believe that at least one of these, B2, B3, B4, B5, B6, B7, is not equal to 0. Okay, meron tayong may statistical proof tayo na at least one of these, whether it's experience, tenure, race, gender, civil status, and number of dependents, at least one of them is not equal to 0. So, ibig sabihin, class, we can improve on the model. Okay. In fact, if we take a look at the, naalala niyo R squared natin ito, there. Yung una, di ba, 16.48%. Ito, 37%. So, yung model natin is able to explain more the variation, the variability of your dependent variable. Ang adjusted R squared natin, 36.19, it will always be lower than your multiple R squared. Be that as it may, yung adjusted R squared natin ng model 1 is 16.32%. Ito 36.19. So mas maganda pa rin talaga si model number 2. Okay. So how do we move now? Sabi natin, we just don't delete all the predictors. So ang gagawin natin, hahanap tayo ng next model natin. And the next model, doing stepwise selection, is to remove the one with the highest, lowest p-value absolute. So, ang lowest p-value natin dito is 0.257 here. So, this is B1, B2, B3, B4. Tatanggalin natin si race. No? Tatanggalin natin si race. So, I'm going to copy this. Okay, copy ko na lang to. No? Copy ko to. Control C. Alright. I go here below. Ito na pala, no? May model 3 na tayo. Ito na yun. So, we remove race here. We removed race. Okay? Remove natin si race. Tapos, ilan na lang? 1, 2, 3, 4, 5, 6 na lang yung predictors natin. Okay? And then let's summarize now. This one. Run natin si Model 3. Okay, so this is our result. Notice, tumaas yung yung adjusted R squared tumaas 36.31 compared to the adjusted R squared here is 36.19. So tumaas ng konti, no? And sabi natin, ang ginagawa natin basis kapag multiple regression is the adjusted R squared, not the multiple R squared. Kasi definitely, yung multiple R squared nito, nung Model 3, is higher, 37.04, as compared to this one, which is only 37.03. Bakit? Kasi the more predictors you have, the multiple R squared, the R squared will always be higher. Pero, kaya nga tinitingnan natin yung adjusted R squared. So, mas maganda yung adjusted R squared ng mas konti, no, in this case. So, pinanalyze natin yung Model 2 for having so many predictors. Alright. So, again, same na naman yung pag-interpret natin. Okay? And then, do we stop here? No, we look at, again, ANOVA. Compare natin si Model 2 and Model 3. Okay, and please take note, make sure that you understand what you're doing. No? So dito, okay, here, Model 2, ito yung kaninang 7 predictors, di ba? Model 3 is the one with only 6. Tinanggal natin race dito. Right? So ito, this will be your unrestricted. This will be your restricted. Okay, take note class ha. Kasi marami nalilito dito. Okay, wag niyong tingnan yung model, yung number ng model kasi arbitrary naman yung number na yun. Tingnan niyo kung ilan yung predictors nitong model na to at saka ilan yung predictors nito. The model with more predictors will be your unrestricted. Okay, and the null hypothesis always the restricted model is better. So ang sinasabi natin, mas maganda yung restricted natin, mas maganda yung 6 predictors lang as compared to 7. So that we don't get confused with the result. Kasi yung iba nalilito sa result eh. Okay? Always base it not on the number, model number, but rather on the definition of what is the restricted and what is the unrestricted. So in this case, unrestricted natin yung 7 predictors. Ha? Yung restricted natin yung 6 lang, yung wala ng race. Okay, so let's run this. Tanggalin ko muna tong drawings ko. If we run this class, okay, take a look now. All right. So, si Model 1 natin, di ba kasama yung race, no? Si Model 2 dito, hindi kasama yung race. And take a look at the p-value. It's 7.97. Okay? So, ang null hypothesis natin dito, the restricted model is better, right? In this case, the one without race is better. So what's our inference? Our p-value is 0.79. So therefore, we fail to reject the null hypothesis. Kaya ang sinasabi nito, mas maganda si restricted. So mas maganda dito yung tinanggal natin yung race, okay, which is actually your model number 3. Okay, dito. So comparing model 3 with model number 2, mas maganda si model number 3. The one with the less number of predictors, yung tinanggal natin yung race. Okay? So there's strong statistical reason to believe. Okay. Writing it class. Ano ba yung ano natin dito? Okay, ito medyo let's write now the null hypothesis here. So the null hypothesis here is that your restricted is better. Now, AKA, what's another way to write this? Okay, ano ba yung difference nila? Si model 2, so this is B1, B2, B3, B4. Okay, ito yung B1, B2, B3, B4, B5. Nawala yung B4, di ba? Yung race. No? So this was our B4, yung race. Okay, wala yung B4, right? So we're testing here that B4 is equal to 0. Okay, gusto natin i-test kung ang B4 ba yung race ba equal to 0 yan? What's our conclusion? Take a look at the p-value. We fail to reject this. We cannot reject this. So there's strong statistical reason to believe that B4 is equal to 0. So, ibig sabihin, wala nang contribution sa race sa pag-explain kay hourly wage. Race is not a significant predictor of hourly wage as far as our data is concerned. No? In another data, it might not be true. So, depende to sa data natin. Okay, pause muna ako, class. Clear yung ano natin dito, yung ANOVA? Clear ba, class? May I request you to please chat? Paano naman please pa-feedback? I want to know if I'm making sense, or do you want me to repeat something here? Please, this is not we're not sprinting here. We're here for the long haul. Notice medyo iba to kaysa kanina, no? Okay, dito kasi iba yung kanina, yung null hypothesis natin kanina. I mean, kanina kasi, di ba, we reject the null hypothesis kasi iba yung hypothesis natin doon. Okay, clear. So, again, class, ang gagawin nyo pag ganyan, pag nag-ANOVA tayo by the way, class, dapat yung mga models natin, dapat pareho yung dependent variable natin, ha? Okay? Hindi pa pwede yung yung iba yung dependent variable na to at iba yung dependent variable na to, no? So, anong sense ng comparison? Iba yung study natin. All right. So, we can say that model number 3 in our case is better kasi model number 3 tinanggal natin yung race. So, it makes sense to remove the race. All right. Then we go back now to do we still proceed? Yes. Proceed pa tayo kasi yung sa model natin may mga insignificant pa rin na Okay, so once again, what will be our leading variable? Look again at the absolute value of your t. The lowest ang lowest natin dito is 1.330. Absolute value, ha? So therefore, number of dependents will now be the leading variable. Okay? So I'll copy this. Ito na lang sa taas para mas mabilis. Itong model natin to, no? Okay. Control C. Model number 3, and now we go to model number 4. And Control Alt I, model number 4. So this is now mod 4. Okay, and then we are removing number of dependents. Tanggal na to. Out of the picture na. Lowest t value, delete. Okay, so model number 4. All right. Model number 4, wala nang number of dependents. Once again, we run this. Okay, and then we can see here. Yun. Now what happened? See, our adjusted R squared natin 36.21. And we can see now that, okay, yung p-value pa rin natin sa ANOVA is statistically significant. And then, okay, meron pa tayong insignificant, si experience at saka si civil status. Okay, so what do we do with this? We test again. Control Alt I. Mag-ANOVA ulit tayo. I-test natin si ANOVA. Mag-ANOVA tayo. Mod 4. It doesn't matter kung ano unahin nyo. Mod 4 versus mod 3. Okay, just take note, class, that mod 4 here is your, ano si mod 4, class? This is your restricted, no? This is your unrestricted. Bakit restricted si mod 4? Wala nang minus number of dependents to. Ito meron pang number of dependents. Di ba tinanggalan natin si number of dependents kay model 4. Okay, so here you're testing. Ang pinaka-test natin dito is that yung B8 to, no? O B7, I think. B7, which is your number of dependents is equal to 0. We would like to test if really yung number of dependents natin is equal to 0. Okay, yun ang difference nila, di ba? Kasi kung statistically equal to 0 to, then mas maganda si model number 4, yung restricted natin. Because that means that there's no sense, there's no point in including number of dependents dun sa model natin. Okay, so we're testing that. Is the B8, B7 ba in this case, the number of dependents equal to 0, which is the same as what we said, your restricted model is better. Mas maganda ba yung restricted natin? Yung mas konti lang yung ano? Yung predictors, no? Again, let's run this. Clear. Okay. Run. Okay, take note, class. Yun. P-value 0.184. So, conclusion. We fail to reject the null hypothesis that B sub 4 is equal to 0. Hindi natin mare-reject yun. So there's strong statistical reason to believe that B7 pala is equal to 0. So number of dependents is equal to 0. Therefore, yung restricted model natin is better, okay, which is model number 4. So mas maganda si model number 4 compared to model number 3. Model number 4 does not include number of dependents. Model number 3 includes number of dependents. So tatanggalin talaga natin si number of dependents. All right? Okay. And then are we now done? No? Are we now done? So ito class, I'm sure we can easily compute for this. No? Are we now done with the model? Di pa. Kasi meron pa tayong, tingnan natin yung ano natin dito. We have two more variables that are not statistically significant. So between civil status and your experience, ang leading variable natin si experience by virtue of the lower absolute value ng t. So ito yung tatanggalin natin. Okay? So once again, copy natin itong model na to. We'll now have model number 5, Control C, where we're going to delete, we're going to remove yung experience natin. Okay. Control Alt I. So we're now doing, Control V. We're now doing model number 5. Model number 5. Model number 5 is we're removing experience, right? Tanggalin natin sa experience. Yan, leaving variable natin yan. Same thing, data, okay, model 5 na to. And then we run this. Run. Okay. What do we now have? Now you can see that yung civil status natin naging statistically significant na. No? Okay? Naging statistically significant na siya. All right. So, we can now see that all our variables are now statistically significant. No? So, wala nang tatanggalin tayo dito. Okay? And if we check model number 5 versus model number 4. Control Alt I. Mag-ANOVA tayo. ANOVA. ANOVA. Model 5 versus model 4. Ano si model 5 class? Si model 5 is the one with, annotate. Model 5 is your restricted, ba? Ito yung walang minus, experience. No? Tama ba? No experience to. Si model number 4 natin is the unrestricted. It has plus experience. May additional na variable to, may experience. So if we run this, run natin. Okay, remember our null hypothesis here is yung B2, I think B2 is experience, no? B2 is equal to 0. So do we reject that? The answer is yes, class. Yung B2 is equal to 0. We fail to reject that. Sorry. Okay, again, ang null hypothesis natin is B2, which is your experience. We are testing if this is equal to 0. Conclusion, p-value is greater than 0.05. So fail to reject to. Fail to reject. We're not rejecting. We cannot reject this. And aka, another way to put it, null hypothesis natin, the restricted model is better. So ano yung restricted model natin? Yung walang experience, ito. Okay? So mas maganda class na walang experience ang kasama natin na predictor na sa mga predictors. All right? And since we have already reached a point where all our predictors are already significant, then that ends our stepwise regression. Okay? Diyan natatapos yung stepwise regression natin. So ang model natin, education, tenure, gender, male, civil status. Ito. So how do we write our model? Okay, our model now will be written as, annotate natin to. Okay. Our model is, all right. hourly wage is equal to at predicted is equal to negative 2.16, gawin ko lang 2 decimal places plus 0.53 times education, okay, plus 0.15 times tenure, okay, plus 1.71 times gender, plus negative 0.68 times civil status. Okay. So this is our final model plus a certain error term. Hindi, sorry, may pala tayo, may hat, so walang error term. All right, so this is our final model. Okay, all our predictors are statistically significant. Most of them at 0.001 and one at 0.05. Okay, so next meeting, okay, we're supposed to have our quiz next Tuesday. Pero let me give you an kasi I'll see magme-message ako, but just be ready, class. If ever paper and pen yung exam natin, tapos classroom tayo sa Tuesday, also bring your calculator just in case. I will not allow class yung cellphones as calculators. Manghiram na kayo ng calculator. Kung sakaling may kailangan i-compute, at least may calculator kayo. No cellphones as calculators kasi pwedeng lagyan ng notes yan. Okay? So, close notes to. No? Close notes exams. Okay, so kindly open the other file that I asked you to, I shared with you. Paki-open nga yun. I'll just quickly tell you what that file is. So that's stepwise regression. Asan na siya? Where is my stepwise? Okay, it's not here. Desktop. Stepwise. Okay, we have some minutes to discuss this. All right, kindly chat please if you have the file already. Someone asked me, sir, paano yun kung you have 20 variables? Tapos iisa-isihin natin yun, so that will take long. That's a very good question. Thank you for that question. Yeah, that's true. If you have 20 variables, stepwise, hindi naman kasi pwedeng sabay-sabay, di ba? Isa-isa lang natin tatanggalin yan, di ba? Okay. So kindly open this. I already placed some notes here. So what's stepwise regression? Ito yung ginawa natin kanina, step by step, iterative construction of a regression model. And then sabi natin may mga living variable. Yung living variable is the one that has the lowest absolute value of t. Okay. The underlying goal of stepwise is through a series of tests, F test, P test, you find a set of independent variables that significantly influence the dependent variables. So, buti na lang may mga computers na ngayon, Kasi pwede nating gawing yung computerized, So there are 3 ways to do stepwise. Yung ginawa natin is backward elimination. So that's what we did. Meron ding forward, which is quite difficult to do. And then meron naman bidirectional elimination. So the most popular one is the backward elimination. That's what we did, Ano yung backward elimination? Linode muna natin lahat ng variables natin, tapos one by one, tatanggalin natin yung tinanggal natin yung mga variables insignificant based on the lowest absolute value of t. Now, just a caveat, may mga limitations ang stepwise regression. In fact, many statisticians don't believe in this. There are many critics. And sabi nga ng iba, hindi na dapat pwedeng itigil na yung stepwise na yan. And there are strong statistical reasons for that. May mga drawbacks Unang-una, minsan iba yung nagiging result. Okay? So hindi siya yung nagiging magandang result, Hindi siya yung optimal na result. So that happens, But for our purposes, Okay, for our purposes, we'll study this. So we're going to make use of the OLSRR package, Ordinary Least Squares RR. So make sure that this has been installed, then i-library natin. Paki-library nga, class. Okay. So I already placed the code here para hindi na kayo magsulat, no? Aaralin nyo na lang, no? Okay. Paki-chat nga please kung na-load na tong OLSRR. This file is actually self-explanatory, no? Kaya hindi ako natatakot na hindi natin makompleto to, but we'll try to cover everything. Madali lang naman to eh. It covers the 3 types of OLS, yung forward, yung backward, at saka yung bidirectional. And there are 2 methods for that, either using the p-value method or the AIC method. Okay, paki-chat nga please kung ready na. Na-load na yung na-install na yung OLSRR. Waiting for the others, and then pakirun na itong model na to. We're going to use this, actually pwedeng mod 1, pero model na lang kasi yun na nalagay ko dito eh. So please run this so that may lumabas na model. Okay, so may model tayo which is just the same as mod 1. Kasi lahat to, no? Lahat ng predictors. Alright, thank you. Okay, make sure that you have run yung model object natin, no? Which is just a regression. This is our model 1 kanina, no? All right. So the first method that we're going to look at is ito. Forward selection. Okay, ano yung forward selection? Okay, ito yung function na yun. OLS step forward underscore P. So this is the p-value method. Yung p-value method, ang gagawin niya, ang pwede lang pumasok dun sa model is if its p-value is less than 0.05. So if you take a look at this, so I'm creating this object called forward. So this is forward selection, no? Forward fit.p. You can name it any way you want. Ilagay ko lang .p para may distinction tayo. The function here is this one. Ito yung function. OLS step forward underscore P. So this is coming from OLSRR. And then we're using the model, and then we have to define ano yung entering natin. Kailan papasok yung variable na yan? Kasi forward to eh. For as long as yung variable magbibigay sa atin ng p-value na less than 0.05. So we can now print this also kasi naka-open and close parentheses. Pag i-print natin to, class. Okay, let's run this. Okay, and you can now see the summary result. All right, so take a look. So dito ang ginawa niya, kasi forward selection to, no? So ang gagawin niya, blank muna, wala munang variables, tapos isa-isahin niya. Okay, and it turns out that the first variable that was introduced was education. Yung R squared, adjusted R squared, binigay kung ano yung nangyari, no? Okay, in fact, ito yung model 1 natin. If you recall, 16.48 yung R squared, adjusted R squared 16.32. And then we have here Malo's CP, okay, which we'll explain later. Tapos ito, AIC. AIC stands for Akaiki Information Criterion. Type ko nga yun, okay? AIC stands for Akaiki Information Criterion. All right. So ano to, class? We will not go into the computation of this, pero ang inaano niyang class, the lower the AIC, the better. Kasi it measures information lost. No? Okay? So the lower the AIC, the better. And ito, alam natin to, no? Root mean square error. This is your standard error. Regression standard error. Naalala nito 3.378. Ito yun. No? All right. Next. Step 2. Ano nangyari? Pinasok niya si tenure. So forward kasi ito, forward selection. So what happened was your adjusted R squared increased. Okay, your CP, your Malo CP went down, your AIC went down, your root mean square error went down. Okay? So and then, next pinasok si gender, and then finally pinasok si civil status. Okay, which is the same as the final model natin kanina, di ba? Education, tenure, gender, civil status. Okay, and these are your R squared, adjusted R squared, and you have your, if you notice yung AIC natin, pinakamaliit ito, 2639. Okay? So, ito class, ito automatic siya, no? Hindi na tayo nag-individually, isa natin. So this is what you call your forward selection using p-value. Okay? Now, I will leave you to run this on your own class kasi mahaba ito, no? Kasi details is equal to true. If you run this, okay, that will be your assignment. Makikita nyo yung step by step, mahabang process yan. And aralin nyo, no? Kung anong, i-run ko lang Okay, medyo mahaba class. If I run this, okay, it's almost time. I hope you don't mind me extending. If you need to go class, you may. I'll just finish some of this. So medyo mahaba, no? A little bit long. Kasi ang ginagawa niya, iisa-isahin niya. Ipapakita niya sa atin kung anong nangyari dun sa forward, no? Forward selection. Okay? So it's a step by step. Parang parang recording siya, no? Step by step. So tingnan nyo. So ang candidate terms and a forward selection method. Ang mga candidate, ito. Yung 7 variables na yan. Tapos ang sabi niya, ito, no? Ang unang ilalagay niya is education. Okay, that's the best. Among the 7, ang pinakamaganda si education. And then this is what will happen. Kung education, okay, this is what will happen to the model. Ito naalala nyo to, adjusted R-squared 16.32, 16.4, etc. No? Tapos yung regression standard error natin 3.378, MSE, right, diba? Okay, mean square error, etc. Andiyan yung mga values, no? Andiyan yung mga predictors. And then tapos, okay, and then forward selection number 2 plus tenure. So it's a summary, no? Ano mangyayari kung isa-isa niyang i-add, no? Isa-isa niyang i-add hanggang matapos yung final So this is a story of how the process was undertaken. So I will not go into that class. I'm sure if you look at this, you'll be able to understand kung ano nangyayari. Okay? There's another method, forward selection then, but this time using AIC. Yung kanina, forward selection using p-value, ito naman using AIC. Now, possibly, pwede magkaroon ng discrepancy ito ito kaya, this is one weakness of the stepwise regression kasi pwede magkaiba yung values. Ito, ibe-base sa AIC. Sabi natin, the lower the AIC, the better. Yung una kanina, p-value, no? Alright, so I will leave you, class, to look at this and try to see if magkapareho ba yung P method at saka AIC method. And you'll see that there's a difference, no? There's a difference. Okay, ito naman, backward selection, ito yung ginawa natin. So, we're using this OLC step backward and then P. Alright? And then dito, since backward to, yung magre-remain lang, P remaining to, kanina P entering. Yung magre-remain lang dapat, yung may mga p-values na 0.05. Ito yung ginawa natin kanina. Alright? So if I run this, okay, take a look at this. Ito. So backward to, backward selection. So una, linagay niya muna lahat, tapos isa-isang tatanggalin. Di ba? This is what we did. No? Tinanggal natin si race. Tapos tinanggal natin si number dependence. Tapos tinanggal natin si experience. Okay? Take note, no? Alright? So, ilan yung natira? Di ba? 7 variables minus 3, naging 4 na lang. So this is what we did a while ago. Okay? Alright. Ito then, backward selection using AIC. Alright, so it's already time, class. I would that you look at this. Okay? So ito naman yung stepwise, so pwedeng backward-forward combination to. So there are 7 methods here. Yung isang method, all possible subsets. So kindly take a look at this, konti na lang naman yan. No? And then, please study this and see what stepwise regression is all about. Okay? So the advantage here is that hindi na tayo magmamanual, no? Kanina kasi nagmanual tayo. Ang ginawa natin kanina, backward selection. But you can do this using OLSRR. Tapos may iba-iba tayong methods. Merong forward selection using p-value, forward selection using AIC, backward selection using p-value, backward selection using AIC, and then bidirectional, no? Stepwise, pwedeng forward and backward. All right? So I hope, please look at this. Okay, sa para hindi naman masayang yung ginawa nating model, and try to study it and discover for yourself ano yung mga ginagawa nitong model na to, especially itong mga to, no, yung mga all possible values. All right. So with that, we end our discussion for today. Okay, thank you so much, class. I hope you learned. I hope you learned something today. Okay, I'll stop recording now.